Okay, we continue. Okay, F need to be bijection. If F is not a bijection, one to one, F is not injective. F is also not a surjective. Why cannot invert such a function? Because we cannot assign to each element in B that codomain a unique element A in the domain such as F is A equal to B lah. Because for some B is either more than one, not one to one is not surjective. Okay, first of all, if you want to inverse, you need to careful because you want to ensure this one is a bijection. Bijection, meaning to say it is a must one-to-one correspondence because you want to replace, you want to inverse the values. Okay, inverse function, let f integers to be integers, be a function with fx equal to x plus 1. Is f invertible? Is f a bijection? If is f one to one? Yes. Is f is onto function? Yes. And then so f is one to one correspondent. Then therefore it is a invertible. You can inverse the function. For example, here we have x plus 1 equal to y, okay, and then x is equal to y minus 1. And then if you have fy is equal to y minus 1 is inverse. Okay, you have to inverse the function. Okay, and then this one is just to check. Okay, 2, 3, 1 is 2, 0, 1. Okay, negative 1 0 and negative 2 negative 1 lah. Okay. Okay, inverse function. Okay, this one is another example. Is this is the function f invertible? Is f one to one? No lah, because you can see fx here. X is 2 and x is negative 2 is also referring to the same functions. So f is not one to one correspondent. So f is not invertible. Okay, we have f 2 is equal to 4. We have f negative 2 also equivalent to 4. It map more than once. It's not one to one. Okay. Okay, and then we have a composition. Let's for example, let G A implies B and function B implies C. The composition of the function f and g denoted by f. Okay, we have g is defined by f composition g equal to f, g, and a. If composition g cannot be defined unless the range of g is subset of domain of f. Okay, the range is same of the subset of domain. Okay, this one. Okay, this one is the example of the composition. You have fx is 2x plus 3 and gx is 3x plus 2, and then find the composition of function f to gx and composition function g to fx. And then this one we solve first the uh, outer inner function first. Okay, fx gx. Okay, we replace fx gx is 2x 3x gx is 3x plus 2, okay, for the function f. And then we compose or we replace the fx 2x plus 3 here, and then we find 6x plus 7. And then when the g x 3x plus 2, okay, gfx we g, and then x is 2x plus 3, and then we uh, this one is replace replace the functions. Okay, we have 3x plus 2, and then the output is not the same. This one is 6x plus 7, this one is 6x plus 11. Okay, and then find the composition for the inverse. For the inverse function, okay, let's say you have the fx is equal to x power of 2 plus 5, and gx is the power of x minus 5. And then you want to composition the function and inverse the functions. First, you need to uh, compose f gx equal to x, and then g fx is you can find x, and okay, fx you replace by y, okay, equal to x power of 2 plus 5, and then x power of 2 equal to y power of 2 plus 5, and then you can find y lah. So you can say the inverse for the f negative 1 inverse fx is x minus 5 lah. Okay, and then fx is equal to 3x plus 8, gx is equal to x power of 2 minus 3 lah. Okay, is it you can inverse or not? First you replace, and then the output is not the same with the x, and then you can say that gx is not the same, is cannot be inverse, cannot the output is not the same with the inverse function of fx. Okay, and then you if you have fx is 7x plus 5, and gx is equal to x minus 5 divided by 7. Okay, if you replace the values, you can find out that fx is equal to gx reversible and invertible, and gx is equal to inversible fx. Okay, this one is basically you need to know, you want to inverse first, you need to be sure it is bijective and one-to-one. And then when you want to compose a function, okay, you must have same range with the subset of domain f, and then you do the inner then inner and outer functions. Okay, this one is another important function. Is we name it as a floor. For example, here the closest integer less than or equal to x lah. Okay, we have 0.5, the closest. Okay, we floor. Floor is like this. Floor. Okay, negative 2.1, the floor is negative 3 lah. Okay, negative 0.5 is negative 1, 3.1 is 3, 7 is 7 lah. Okay, this one for the exercise, please upload to Padlet lah. Okay, this one is the graphical for the floor. Okay, if you have for the floor, negative 1.5 is equal to 2 lah. Okay. Okay, this one is important function also, ceiling. Ceiling is the greater than or equal to lah. Okay, 0.5 is you ceiling to 1, negative 0.5 is 0. This one we take the upper limit of x. Okay, and then upper ceiling for negative 2.9 is 2 lah. Okay, the greater number, the greater number. Okay, negative 2.9. The greater number is not 3. Negative 3 is greater number is negative 2 lah. Okay. You also use this one, use this exercise and then upload to Padlet lah. Okay, so far, do you have any question?